Hello, we're going to take a look at the scientific revolution. As we move through the scientific revolution, be sure to respond to any of the focus questions as we go through it. You can pause at any point in time to stop if you need to. You could also watch this on one device and respond to it on another, maybe watch it on your phone while you're responding to the focus questions in Google Classroom. So as we move forward today, we're going to look at new discoveries in sciences, understand the scientific method, which is something I'm sure you've learned about a little bit in your science classes. We'll look at the contributions of people like Galileo, Copernicus, Newton, and other scientists who kind of made the scientific revolution what it's best remembered for. So you look at question number one, where did people look to for answers about the universe prior to the scientific revolution? Well, as we learned when we looked at the Dark Ages, we kind of saw that reliance on the church, Catholic Church in particular, for all aspects of knowledge. They kind of let the church kind of dictate to them what to believe and how to think. They kind of trusted God, the church, the Pope, more than even their own thinking or their own eyes would tell them. So when we look at the scientific revolution in two, it was a complete change in how people view the world. And anytime you see a revolution, the complete change aspect, that's kind of the key there, complete change. I'll even bold that for us. So this will apply when we look at additional revolutions moving forward. You start with a complete change, and then you explain what that change might be. So people became questioners rather than acceptors. They began to challenge long accepted theories, began to think for themselves. 3, how did people view the universe according to the ancient Greek astronomer Ptolemy? His ideas supported the notion that the Earth was the center of the universe, that the sun and the planets revolved around the Earth, and the church supported this notion. The church believed that since, in their belief system, God created everything, including Earth, that of course if they put humans on the Earth, it would make sense that the planets and the sun, everything else would revolve around the Earth, which is what they believed God had created. However, other scientists like Nicholas Copernicus, he came up with a different theory. It's called the heliocentric theory. The one we looked at previously was the geo or Earth-centered theory. So we look at the heliocentric theory. This was the idea, this is the one that's scientifically, factually true, that the sun is the center of the universe. Everything revolves around the sun. It was very controversial during this period of time in history because it went against and challenged the church. Challenging the church, as we're going to see, could lead to a lot of trouble for anybody who tends to do so. Other astronomers like Tycho Brahe, Johann Kepler, they helped to contribute to Copernicus's theory. Tycho Brahe used observations and calculations to prove his theory. Johann Kepler used math to map out the elliptical paths planets took to go around the sun or revolve around the sun. Another great person during the scientific revolution, somebody I'm sure you've heard of, Galileo Galilei. He was a great astronomer. He developed an early telescope to observe planets. He was the first to discover the moon had mountains and craters on it, and he identified also the moons that were around Jupiter. So he's going to be kind of a transformational figure during this particular period of time in history. That's the early telescope that he used. Of course, the Catholic Church is not going to react very well to Galileo's ideas. Called him in before the Inquisition. They demanded he recant, which means to formally take back your claims. He was forced into house arrest for the rest of his life. So he would spend the rest of his time kind of studying from his home. Why do you think the church was against the new discoveries during the scientific revolution? Well, of course, it went against their doctrine of the church's teachings. They feared it would lead to more people challenging the authority of the church, and they wanted obedient members of society. They didn't want people who would be willing to challenge the ideas of the church. They feared as more people challenged, then maybe they could be exposed to perhaps not necessarily having the factual information. They thought that maybe they would begin to prioritize science over the church or God. And they would turn out to be correct. Eventually, they, of course, will. Nine, why would the social, political, and artistic changes of the Renaissance encourage changes in science? So we're going to see the connection between the Renaissance and the scientific revolution here. The changes in other areas like paintings and painting to perspective and things like that, the humanities, kind of thinking for yourself, emphasizing people first. They all became kind of related or linked to advancements in the sciences. 10, why did many scientists in the church reject Copernicus's hypothesis that the universe was heliocentric? While some religious leaders obviously wanted to continue what they've been saying for such a long period of time, that God had created humans, and it only made sense that humans and Earth would be the center of God's universe. And some scientists supported this because they wanted to remain in good standing with leadership within the church. So maybe even scientists deep down didn't necessarily believe it, but they kind of said what the church wanted to hear because they wanted to remain in good standing, especially in light of seeing what happened to Galileo for questioning the church's teachings. 11, how might the Reformation have shaped the church's response to Galileo's discoveries? Well, the church had already been dealing with dissent throughout Europe. They wanted to keep Galileo in line. So the punishment against Galileo was harsh. They kind of used Galileo as an example. That's unfortunate for Galileo and unfortunate for society because, of course, Galileo being a great scientific mind and the fact that maybe he was somewhat reined in was kind of problematic, especially for that period of time in history. Now, the scientific method, of course, I mentioned before, is something I would assume you're familiar with. So the basic way in which the scientific method works is you state a problem, you gather information, you come up with a hypothesis, which is an educated guess, and then what you do is you test or experiment the hypothesis. You record and analyze data, you make your conclusions, and then you share that data and answer any questions that may arise. Now you can see there, it's kind of like a little flow chart of the scientific method. State the problem, gather information, form a hypothesis, test the hypothesis, analyze the data, draw conclusions. If it's not supported, you modify the hypothesis. If it's supported, you want to repeat it several times because you want to make sure that you try it multiple times to see if you get the same outcome. Why is the scientific method so important? Well, it allowed scientists to have a reliable method to study and test ideas and help to bring about pioneering ways of thinking, kind of the general idea that you should continue to make your best guesses, make an educated guess, and kind of test and kind of move forward that way. Okay, next, we're going to look at some of the great scientists during this period of time. Andre Vesalius, the first to accurately detail the anatomy of the human body. So things you kind of take for granted. These are types of things that are being developed during this period of time, kind of identifying different parts of the body. William Harvey described the circulatory system and the heart, so you see how the blood flows. Anton van Leeuwenhoek, he used a microscope to discover microorganisms. Robert Boyle, he modernized chemistry, identifying the elements in the compound, something that you have to always memorize, I suppose, in your chemistry class. Isaac Newton explained the theory of gravity, something I'm sure you're familiar with the whole idea of the apple falling from the tree. He developed calculus and new laws on the universe. 15, in what ways did scientific method differ from earlier approaches to learning? Well, during the Middle Ages, people, as we mentioned earlier, were acceptors and not questioners. Somebody told them something from the church or wherever they might have learned it. All right, that makes sense. I'll just accept that as being true. People took their church teachings as scientific fact, did not test or challenge church theories, especially during the Dark Ages. We look at the Renaissance and the impact it had on medicine during the scientific revolution. The Renaissance sparked scientific investigation into what could be done better to understand how humans lived. With experimentation came new ideas and the understanding about medicine. The lesson reflection: why did citizens need to turn away from the church in order for progress to occur? How has turning away from the church teachings impacted modern day society? In order for truth to become known, citizens needed to question and test theories. Modern political issues like same-sex marriage, abortion, stem cell research, Darwin's theory of evolution have all come in conflict with church teachings, and therefore we had to move forward and beyond what the church might think is best and kind of do what's best for society and for all human citizens. Hopefully you enjoyed our discussion on the scientific revolution. You could always pause wherever you need to if you need to get any information down, or kind of rewatch it again to the spot you might need. But until next time, Mr. Clarke is Out.